Hi, I'm Steve, an engineer at Microsoft, and this session is about Python. And the question you should be asking straight away is why? Why bother? Why do we need another programming language? We already know JavaScript, a flexible dynamic language for getting problems solved quickly. And we've all got C++ or C# or Java, robust static languages for critical software infrastructure. Why would you add Python to this mix? The reason is there's a gap. Maybe you're not aware of this gap. Maybe you're forcing the problems that come out of this gap into JavaScript or into C# or C++. This gap is where problems come from that can't be solved easily with the other languages. This gap is why big financial companies, all the big resources companies, the big software development companies, all the universities and government organizations are using Python, because Python fills this gap between other languages. Let me get a bit more concrete. How often do you write a web app? I don't mean big, mega-scale, Facebook-sized web app. This is a web app for people on your team. Something small, low traffic, tens, hundreds of visitors daily, but it's absolutely critical infrastructure. It needs to work. You could write it in JavaScript. You're going to run the risk of unexpected errors coming up, data types being converted when you don't need them to be, and errors flowing through into the results. Or you could write it in C#, C++. Now you have a software development life cycle to deal with. You've got compilation, you've got deployment, you've got a whole lot of issues where if you pick Python, which fits this gap, you'd have a simple scripting language, robust typing system, values not changing when you don't expect them to, and an ecosystem of libraries that really support developing these sorts of apps. Maybe you do data processing. Maybe once a day, you've got to open up some log files, security logs, HTTP access logs, unit test results, and process them, looking for anomalies, looking for patterns, looking for trends. And currently you're doing this manually. You could write a log processor in C++. It'll be the fastest log processor ever that runs once a day. Or you could write it in JavaScript, and at some point you're going to start losing data when the numbers get too big to fit into JavaScript's numeric types. Python is a language designed for this kind of task. Loading in log files, scanning through, regex, processing, structured data, semi-structured data. And when you surpass all of that and you want to get into machine learning or other advanced analytics, Python has state-of-the-art libraries freely available, and it's where all the cutting-edge research is coming out as well. Perhaps rather than a script, you need to do this interactively. You have the data. You don't know how it looks. You don't know what insights you want to pull out of it yet. If you start doing this in a static language, a compiled language, you're going to spend all your time in the compiler, make one little change, wait for it to rebuild, try it out. Make one little change, wait for it to rebuild, try it out. Have you tried doing interactive work in JavaScript, sitting at the console? It's not the language that's been designed for doing interactive data analysis. Python has a huge ecosystem in this area. It's a language that's designed for using from a command prompt, from a terminal interactively, and it has the libraries and the interaction tools to make it really powerful. Or maybe you do systems administration. You write PowerShell scripts for a living. You write batch files. You write bash scripts. You have tasks that regularly need to be automated, but they aren't super intelligent tasks, super complex tasks. It's a matter of sequentially triggering other steps from other processes. What happens when you end up with a huge collection of PowerShell scripts and your organization starts rolling out Linux machines? What do you do then? You've written bash scripts for everything, and now you need to support Windows. What then? Python is cross-platform from the beginning. You need to make an effort in Python code to actually make it not cross-platform, to make your own scripts locked to a certain platform. But the API that it exposes is designed to look the same across as many platforms as possible. You can take your Python scripts running on Windows and run them on macOS, run them on Linux without modification. But maybe you know about these problems already. Maybe you're familiar with the gap and the issues that you need to solve coming out of it. Maybe you even know that Python is a good tool for you to do this, but you're worried about losing the great support you already have for C# and JavaScript and those other languages. This is why Microsoft has a Python team, so you don't need to sacrifice when you switch from these languages to Python. Do you love Visual Studio? We have Python support in it. Are you already building on top of Azure? We support Python running on Azure. We support Python managing Azure. You don't need to sacrifice because we have a team that does the work for you. Let's take a look at some of the things we have to offer. Okay, so I've jumped into Visual Studio and we're going to look at an internal website. So I'm just going to start by cloning a GitHub repository, which I've already made. This is public, you can go check it out. It's for an internal site for our company, and the site is called Do I Still Have a Job? So it's very important functionality that we need to get right. If people start going to this website and getting wrong information, we're going to be in a lot of trouble. So it's really important that we don't have ways that the data model could be corrupted, that data could be changed, that types may conflict, that errors may occur without being able to detect those early, which is what Python excels at. So I'll just quickly start running so we can have a look. And I can show you what this site does. So this is it. It's fairly straightforward, but like I say, important functionality that we absolutely need to be getting right. And when we don't get it right, we have a way here to fix that. And so now I still have a job, which is an excellent place for me to be. So what code goes into doing this? This is based on the Bottle framework. So we get to define each of the pages that are involved in a very small section of code each. And these are associated with templates, written simple HTML with a few substitutions at runtime. This is a very simple site that has not taken a lot of code to get going. These are all of the handlers. I can dive into one of these functions with go to definition, normal Visual Studio support, and see our data model that's involved here. We're calling into the table service for Azure using our Azure SDK for Python. And we're just going to get an entity. So we'll get the employee based on their name and use the data model to see whether they have a job or not. And if we don't find them, we assume they don't have a job. So there's a very small amount of code that's gone into here, but it's definitely code that is it's either going to succeed and work correctly, or it's going to fail very early while we're testing before we've deployed it with a detailed, precise error message. So this is great, but the next step is actually deploying it. But though it's a simple site, we still need to get it up and running on the internet somewhere. So I'm going to deploy this to Azure Web Sites. To do this, I have a deployment script, which is part of the code, which is going to use an Azure Resource Management template and the Python Management SDK for Azure to deploy. So I will start this running in the background so that we can see the results when it's done. But let's have a look through what this script is actually doing. If you're familiar with deployment scripts, then you'll recognize the structure. There's a set of constants up the top, which define the certain parameters of our site. These are hopefully the only thing you need to change in order to deploy a separate site in the future using the same script. The first thing we do for Azure Resource Management is create a resource group. This is a label or a container where we can put all of our resources, that relate to this service. It makes it easy to manage them as a group, and eventually we'll use it to clean up our entire deployment in one line of code. The next step is deploying the template. I'll collapse that for now, and we'll have a look at the code. Again, very simple. We're making one call into the deployments API, where we're going to create or update a template. This will do an incremental update. So if we redeploy the site without destroying everything, it's simply going to update the minimal amount it needs to update in order to have the deployment match our template. And we get to provide parameters. These parameters are marked in the template. They get substituted in on the server side. The template is effectively a static JSON file, which means parameterizing it from other situations other than in Python code can be complicated. So rather than doing that, we'll use the template parameter support on the server to substitute values in. These are the values being substituted. As you can see, they've simply come from our constants up the top of the file. After the deployment's been created, we'll use the websites API to get the site, and from here we can list out the host names and eventually help the user navigate to it. These two lines of code are using the standard built-in web browser module in Python in order to open the user's default web browser. These are cross-platform. You can run this script on Windows, Linux, Mac OS, and every part of it, including these lines here, opening the user's default browser, will work. This is because Python does such a good job of being cross-platform. And finally, we have the one-line command to clean up our entire site. That will delete the site, it will delete some of the background storage that we create, and there will be no trace left, nothing that's costing us any money to leave running. So let's have a look at the template. As I said, it's essentially one big JSON file. But because JSON syntax matches Python's dictionary and list syntax, we can represent it in here as a literal, and we get a bit more flexibility. We can add comments in wherever we like. We can use variables in Python instead of having to be restricted to string literals. This section defines the parameters that we're going to substitute in later. But the interesting part is the list of resources we need. The hosting plan that we deploy is a server farm, effectively. This lets us group together the websites and put them under a certain SKU, a certain level, a certain set of features and cost that it's going to be costing us to use. I'm using a free plan right now, and there's a few others that you can choose from. The storage account is where we'll keep the data. Obviously, if the website gets reset, anything that's in memory will be lost, and so we want a storage account so we can use table storage to keep the list of employees. And then we deploy the site. Within the site, there's a couple of more resources that we want to configure. The first is application settings. These are exposed as environment variables into the Python code, and you can see these here. We're passing in the name of the storage account that we just created, using a parameter to substitute it, and then we're going to pass in the access key for that storage account. And here we're using a special function so that no person ever needs to look up what that storage key is. We create the storage account, it has a randomly generated access key that we then request as part of deployment and inject it into the web app so no one ever has to look it up and find out what it is. And then the last resource we configure is source control. Rather than copying the files from my local system, I'm setting up an association with the website, linking to the repo URL, which is the GitHub repository. This means that on initial deployment, the website will be copied down from the Git repo into the website and deployed, and every time I push to my GitHub site, it will automatically update the website. Let's have a look and see if it's finished going. So the website has been deployed, we've deployed Contoso internal apps, and the site is now available. Do I still have a job.azurewebsites.net? Let's browse there now and see it in action. So you can see in just a few minutes, we have a website up and running live on the internet with all of the options available through Azure Web Apps. You could add authentication to this. You could add a special domain name. You could add auto scaling, whatever you may need. And it's all available from Python code using the Python SDK for Azure, using Azure Resource Management deployment templates, and available from any platform, Windows, Mac OS, or Linux. Python fills a gap between the other languages you know. It's used to solve problems that are too important for JavaScript and its weak typing system, but don't need the strict contracts and padded cells of a static language. When you need to be sure it will work, you should consider Python. When it needs to be ready to work now, you should consider Python. When you need to be using a language trusted by financial organizations, resources companies, software development companies, universities, government organizations, you should consider Python. And when you need to be using the best tools and platforms, the team at Microsoft is here for you.